Now we are going to add a sensor to our BOE-Bot or BOE-Bot. And the first sensor that we're going to use is called the Whisker sensors. And these are little touch sensors that are provided along with your parallax kit. And what they look like is this. So they're these really thin conductive wires, and what you're going to do is you're going to breadboard a little circuit on here, and you'll put these little 3-pin headers. And essentially what happens is that these wires are going to be connected to your Board of Education shield, and they're actually grounded. So they are logic low. And then what happens is that when they're pressed, they'll actually bend back and hit one of these pins, and it'll change the logic level on one of the digital inputs. So the way that it works is you're going to have these resistors on here, and they will pull a digital input up to a high, and then when one of these is pressed, you will actually then see a change in the logic level from a high to a low. So the first thing that you need to do is add these to your robot. So what you're going to do is, here's the parts list from the parallax tutorial. You got the 2 whiskers. You're going to have these little nylon washers that are non-conductive. And you're going to need these longer screws. So you're going to need these 7/8 panhead screws, and you're going to pop these babies right on the top of your BOE board. And then the way that you have to do this is make sure that with respect to this nylon washer, you have to have one of the whiskers below and one above, and that way they won't bump into each other. Then what you're going to do is you're going to breadboard this circuit. So you're going to have 3-pin headers that you'll place in this position and this position, and it's important to put them in the right position. So this top one relative to this picture is 1, 2, 3, 4, 5, 6 holes down, and then this one is 7, 8, 9 holes down, and that's just, it matches the length of these whiskers. And then you're going to put a 220 ohm resistor from this 3-pin header into this hole over to pin 7, and then you'll do a 220 over into pin 5. And these are going to be the digital inputs that we're going to read from. And then you're going to put a 10 kilo ohm resistor from the pin up to +5 on each of them. And the way that this works is that the +5, when they're not contacted, okay, all that's happening is that the digital input basically sees this resistor and then pulled up to +5. So that's a high. So when it's not in contact, you see a logic high. And then if you do make contact, so let's say for example that you pressed this whisker in, it would come over and it would move and it would touch the pin and it would pull it to ground, because the metal on these screws is actually at a logic low or ground. And what happens then is that now you have a 220 essentially seeing a ground over here, and it's able to pull it down because the resistor pulled down is much stronger or a lower value than this 10K pull up. Okay, so essentially what's going to happen is you're going to have a left whisker and a right whisker, and when you press them in, you'll see a low on either 7 or 5. Circuit-wise, this is kind of the circuit diagram for what it would look like. Normally the whisker is not when it's not pressed, the switch is essentially open, and you pull it up to a high. When it's closed, what happens is that it pulls the input down. Okay. All right. So what we want to do at this point is go ahead and build that thing. And here's mine right here. You can see mine going, and I have my tone still playing. Okay, so you can kind of see my whiskers right there, but it's exactly the same as what we have in the tutorial. And leave your buzzer on there also. Okay, so now that you have that, obviously stop the video and breadboard that up. Let's go ahead and program this. And so what I want to do is I want to test the whiskers. Since I already have my buzzer on there, my piezo speaker, what I want to do is I just want to write a program that will read the whiskers, and it will beep whenever it sees either the left or the right actually go. Alright, so let's do the following. I'm going to come into my Arduino folder, or actually no, what I'm going to do is I'm going to start the Arduino development environment, and then I'll start a new project. Okay, so I've got myself my Arduino Sketch, and I am going to, first things first, I'm going to save, and this will put it, I want to put it right into my working directory that we've been working on my desktop. So I come to desktop, Arduino, And I'm going to call this Chapter 5, Activity 1, and that corresponds to the parallax tutorial where all these images and ideas are coming from. And I'm going to call this Whisker Test. Okay? Alright, so we have our Whisker test, and we're ready to go. So let's go in here and see what we need to do. So the first thing that we want to do is let us do the following. First thing I'm going to do is I'm going to print, I'm going to set up my serial monitor. So I'm going to do serial.begin. And I always want to do this just to make sure that I'm running running my actual program. So I go ahead and do that, and then I'm going to do a serial .print line. I'm going to say starting Whisker test program. Okay? And then I know that my program is actually running. Alright, now first thing I want to do is I am going to set up the whiskers. Now, if you recall from prior videos, the way that you do this is we need to set up the digital input, or I/O, as an input and use the pin mode function. Okay, so pin mode is how we set up the pin, and on pin 5 we are going to make it an input, and pin 5 is going to correspond to the left whisker, and I'll put a comment there just so I can make sure. And then pin mode, pin 7 is also going to be an input and that's going to be the right whisker. And when you start playing with this, you'll see how the whiskers actually crisscross, and so the left whisker is going to hit the upper 3-pin header, which is attached to, let's see here, they do crisscross. And let's see, okay, so I think that is right. Yep, they crisscross. Okay. Okay, so now they're set up. It's like, all right, now what? Well, what we want to do is we want to read from them. Okay, so what I'm going to do is I'm going to do a couple things to make sure that I'm actually working right here. Is I'm going to read from the pin, and then I'm going to look at the value of it, and I'm going to say, okay, if it's not pressed, don't do anything, but if it is pressed, play a tone and also write it to the screen. Okay, alright, so let's go ahead and remember how you do a digital read. Well, actually, I don't know if we've covered that. So what I'm going to do is I'm going to do a data type called byte, and I'm going to define W left, and this is a user-defined term that I'm using. Okay, so this is, I'm making up W left. Now, byte is going to be the type of this new variable. Okay, and then on the same line, I can actually use the function digital read. And now what it's going to do is it's going to go out and it's going to go to what pin number I give in the argument. So this right here will come down, and when it's executed, it will go grab the value on pin 5, which is our left whisker, and it's going to assign it to this new variable that I have, which is called W left, and the type of W left is byte. Okay, all right, and so the value of W left is either going to be a 1 or it's going to be a 0. Now we know that the pin itself is just a single bit, right? It's just a 1 or a 0, high or low, but we can't have a binary data type. We can only have in chunks of 8 bits at a time, so that's why we have to do byte. But it doesn't matter because the value, all the other bits within the 8 bits here are just going to be zeros. So the value of this W left will either be a 0, which is 0, 0, 0, 0, 0, 0, 0, or it'll be 1, which is 0, 0, 0, 0, 0, 0, 0, 1. Okay? Okay, so I got it. All right, so I read that and I stuffed it in that variable. And notice that I'm in this loop, so I'm just going to continually read that thing. Well, let's go ahead and read our other guy. Let's do our right whisker, which is on pin 7. And we'll come in here and we'll make that a W right. And I've read them. Okay, so life is good. Now you say, well, what do you do with this stuff? Well, why don't we print these to the screen and take a look at what this might look like. So I'm going to do the following. I'm going to go ahead and I am going to do serial.print, and I can just do W left, and that's going to print either a 0 or a 1 to the screen of what left is. Notice I'm not going to put a return on there, because then I'll come right after it and I'll do a serial print W right. And what this should do is just print zeros and ones, and it'll continually do this. And let me put a little delay in here, so I'll delay 50. And let's go ahead, save this, and compile it, make sure that everything is okay. So while that's compiling, I'll bring over the monitor here. Let's see. Alright, so it's going to compile. And we're almost ready, and then we'll download this baby. Alright, waiting for it. Okay, looks okay. So now I download this program. Okay, so I'm going to come over here, and okay, so check this out. It's going crazy. It's writing all these on the same line. Let's go ahead and put a return after this so it's a little easier to see. I want it to scroll vertically, so let's save that up. And once you get the first program on here, it seems to go a little bit faster. So now I'm going to do this. Alright, and here we go. So it's going to print left and right. Okay, so starting Whisker. Now look at what's happening. So it's going 1, 1, 1, 1, 1. Now, here's what's cool about this. I'm going to show you a few things. So first of all, here's mine, okay? And this is my left whisker. And if the camera's a little, might have this flip, but if I press that, notice what happens is that the left column goes to 0. That's because, remember, these are being pulled up normally with the resistors, and when I push it, I short it to ground or make it a low. And I can actually do both right and left. And I want to show you something also interesting. You need to have the power for this to work on, let's see here. See that you need to have this +5 strip up here on, so your power switch has to be in at least the 1 position, or yeah, position 1, because if it's in 0, look at what happens. I turn that to 0, and all the zeros go to, or all the values go to 0, and it's because what I've done is I've turned off that +5 on there, so it's essentially is unpowered, so it's not able to pull it to a 1. So these whiskers really only work if you have the power to that little +5 strip in there. Okay, so that's pretty neat. Let's go ahead and throw a tone in here. Now this, we're not even doing anything. All we're doing is just looking at, we're just printing left and right. But let's go ahead and put this in a decision statement, and we'll use our tone function that we played with a little bit last time. But this if-then structure is really neat because we can use this going forward to kind of make decisions based upon these whiskers. So here's what I'm going to do. I'm going to come right here and I'm going to say if, and I'm going to open up a little statement right here. And what I want to do is I want to say if W left equals, and it's double equals is a comparison. So if it's a 0, that means the left was pressed. Okay. And I'm going to put that within its own parentheses so that's really obvious what I'm doing. So it's like if W left, bah. Then I'm going to say and then I'm going to say W left, or excuse me, I'm going to say W right is equal to a 1. What I have essentially coded is the following. This means that left was pressed. Okay? So remember, left is, if it goes to a 0, that means that the left whisker was hit with something. And then what I'll do is I'll open up curly brackets and I'm going to do something. So what do I want to do? Let's play a tone using the tone function, and the piezo speaker is still on pin 4, and let's play a 1000 hertz tone for something small like 50 milliseconds, and I tell it to go for 50 and stop after 50, but I want to delay 50 to let it actually have time to do it. And check that out. I mean, how awesome is that? Alright, so now what? Why don't we put another tone that's a different frequency if you happen to have the right one pressed? So the way that you do that is I do an else statement after this, and I'm going to copy this entire segment right there, and I come down here and I go else, and then I pop my if there, and at this situation what I want to do is I want to see that the left was not pressed, it was the actual right pressed. Okay, so now this one is going to be, I'll put my comment on here as right pressed. And so then if the right whisker was pressed, what I want to do is let's play a tone, but let's play a different tone. So let's play 2 kilohertz, okay? And then finally, let's do the exact same thing where I'm going to do a third else if, And in this situation, both of them are pressed, and in that, which is perfectly valid. But this time, I'm going to make, so it's 0 and 0 is the condition, and my comma will be both pressed. And let's play a tone that's like 3000. And what we can do is we can go through this if-then statement, and we'll still print the values out, so that's fine. But let's go ahead and save this up, and let's download this, and let's see what happens now. Okay, so it looks like it's going to compile okay. And I'm sitting here. And it's off. Okay, so now let's go ahead and press the left whisker. Do you hear that? So you can hear. Okay, so my left whisker, that's a kilohertz. Then here's my right whisker. A little higher. I'll pull this up to my... So now, how about both of them? So left, right, both. So we did it. So this is great because you can see how you can, I mean, other than giving us some sort of feedback on what's actually happening, you can see how you use these if-then statements to actually do something cool and make decisions. What's neat about this is now we can actually use these whiskers to direct something such as motion of the robot, and we can actually use it for navigation. So that would be, so at this point, this would be a good thing to do is go ahead and after you got your whiskers on here, go ahead and write these programs and play around with just experimenting on how much force it takes and getting the program to actually work, and go ahead. Now we have our whiskers on here and we know that they work. Let's take a look at how we can use them to do an obstacle avoidance, or at least influence some of our locomotion. So we're going to do this activity 3, navigating with whiskers. The reason it would jump to activity 3 was because we're following along the parallax tutorial, and so activity 2 was hooking some LEDs to the breadboard so that you could see them light up whenever you'd have a whisker press. But we have the tone on there, so we don't necessarily need that. Okay, so let's start with our last program, activity 1, whisker test, and I'm going to add some locomotion to it. So the first thing I want to do is I'm going to save this off. First I'll save this, then I'm going to do a save as, and this is going to create a new Arduino Sketch for me. And so I'm in my right folder, and I'm going to call this chapter 5, activity 3, and I'm going to say, instead of being whisker test, let's call it whisker roam. Okay, so we're off and running. And here's what we're going to do. We're going to do locomotion, okay? And we've kind of seen that, we need some functions to do this. But when we did, up until this point, you can kind of create your own functions and stuff. But what I want to do is, since we're going to be talking about, trying to communicate what we're actually doing, is I want to use these functions, okay? And if you use the same functions, it'll make it a lot easier to kind of follow along. So I'm going to create 5 functions, and one of them is going to be halt. Notice void. It doesn't return anything, so it's just going to stop. And all we do is rewrite the servos 1500 microseconds each, okay? So instead of writing these 2 lines all the time, we're going to do halt. Then I want to create 2 functions called move forward and move backwards, and in these ones I'm actually going to pass a time in. So I have void move forward. The void means that this function will not return anything, but I am going to pass in a parameter, and I'm going to pass in a parameter with the variable named time that'll be used within here, and it's of type integer. And the way that I use it is when I move forward, I'm going to do a right microseconds. Let's go full speed ahead, 1700 on the left, 1300 on the right, and then let's delay for the amount of time that was passed in. So when I type time here, it's going to use the variable that was passed in. Exact same situation when I do move backwards, except that I'm going to just reverse the motors, so it's 1300 on the left, 1700 on the right, and then I'll delay again. And this is going to save me a little bit of effort when I'm programming. And then let's do a turn right 90 and a turn left 90. And these ones, the 90 refers to degrees. So we're just going to go ahead and spin, and then the delay is embedded within here. So it's not, you don't pass in the time. You're just going to have to mess with the delay to make it turn exactly 90 degrees. And this really varies depending on the surface. So when I do this on my desk, it spins really quick. But when you do it on like carpet, it doesn't spin as fast, and so the angles don't come out exactly at 90 degrees. But we want to have these 5 functions in there. Okay, so I'm starting with my program, but let's crank these functions out really quick. So I'm going to go down below my program. And what I'm going to do is I'm going to type these in, and we'll type them in together just to so that we're on the same page. And I'm going to put this big comment on here so that I know that this is functions. So functions. Okay. All right. Then let's go ahead, and then there's a lot of copy paste. So I'm going to do a void. Let's do our halt. Okay. And then old halt is going to do this. All it's going to do is go servo left right microseconds 1500, and then we're just going to write the left, or excuse me, the right servo right 1500 seconds. Okay. Done. Now check this out. I'm going to copy and paste that, and let's go ahead and do our move forward function. And remember that I'm passing in an integer, which is time. And in this situation, I want my left motor to go 1700. I want my right to go 1300. And the difference here is that when I do my delay call, I use the variable time. Okay, so now I've got my second one done. And if I have a typo in here, I'll fix it when I compile. Now backwards is actually really easy too. So I'm going to do move backwards. I copy my function from before. So move backward, move forward. And all I do here is I just reverse these polarities. There's my third one. And then we're going to do, let's call this one, what did we decide? Turn right 90. And what I'll do is I'm not going to pass in anything, but I am going to write both of these. I'm going to go 1600 and 1600. Okay, so you probably noticed that I biffed this baby right there. That should be 13. Okay, cool. And I don't go full speed on the turns. It just seems like if you go full speed, it flies. So, but you can do whatever you want. I'm going to do 1600, and then I'm going to delay. It's about 800. We can see what it turns out to be. It's easy to change. All right, let's do turn left. Okay. All right, so I turn right is 1600 on each, and then this one's going to be 1400 on each. Okay, great. So I got myself 5 really nice functions, and so now let's go remind ourselves how we turn these motors on. Okay. So the first thing we want to do is above your setup, we need to attach, or excuse me, we need to do some including. Okay. So the first thing is I'm going to do pound include, and then I'm going to pop the servo.h header in there, and use those greater than or less thans. All right, so great. I've grabbed the servo, and I know that I typed it right because it turned orange. And then I'm going to do servo keyword, and I'm going to create these instances, servo left and servo right, and those are now my user-defined names for the left and right motor. And now what I can do is I can come into the setup, and what I want to do is I come into my setup, and I'm going to do starting Whisker test program. I'm going to go Whisker Roam program, and we're still using our whiskers. Okay, so we're going to do the pin mode here. Pin mode, life is good. But now let's get these servos attached. So I'm going to do servo left dot attach, servo left dot lowercase attach, and I have my left on pin 11, and I have my right on pin 12. And if you have them on different pins, that's fine. I just remembered that pin 13 had a little glitch on it, so when you'd start it off, sometimes it would move one of the servos. So I just moved them to 11 and 12. It's kind of cool because if you do move them to another pin, all you do is just change this number. Life is good. First thing I want to do is in my setup, I'm going to go ahead and halt so that they don't take off. And then I will delay, let's give it a second just before we do anything. I don't want the thing just flying. I want it to just do something. Okay? All right. So now we got it. You know what we could put a tone here if you wanted to, just to know. Halt. Delay. And you want to do a tone? Why not? Let's just do a tone. 1K for 500. And then we'll do a delay. 500, just to kind of let us know the program's up and running. All right, so now I'm sitting here, everything's ready to go, and check this out. I'm going to come into here, and I'm going to say, I'm going to read from my left and right whiskers again, just like I was doing before, and if there's a press on the left, press on the right, these decisions will happen. What we don't have in this if then is actually a final else clause. So what does it do when you don't have anything pressed? And we didn't need anything before because we didn't want it to do anything, so we just left it out. So essentially it was not going to play a tone. But we want it to do something now when we don't have anything pressed. We want it to actually move forward. So what I'm going to do is I'm going to add this final else little clause, and I'll fire up a curly bracket, and I'm going to move forward. So I'm going to move forward, and you only want to move like a little bit forward, because remember that this loop is going to be going through just over and over and over and over. So you only want it to move just a little bit forward before you go back and check to make sure that the whiskers haven't been pressed. Okay, so move forward 20 microseconds, and then come back in. And what should we do if we run into something? Okay, so for now, let's do the following. Let's just test this out and make sure that it's working. If I get a press on the left whisker, for example, what I want to do is I want to move backwards and halt for a second, okay? So what I'm going to do is I'm going to put right here, in this one right here, and we'll test it first. We'll do it saw the left was pushed, so it does a move backwards, and remember you pass something in. So I'm going to go, let's do a second and a half. So I'm going to move backwards 1500 seconds, and then what I want to do is I just want to stay there for 2 seconds. Now what's going to happen here? It's going to come through and it's going to be moving. Okay, so it's going to start off, play its tone, and it's going to move, and it's moving. All of a sudden, one of the whiskers is pressed, and it's going to move backwards and sit there for a second, and then it's going to move forward again, because it's going to do this, and then it's going to delay for 2000 microseconds, and then it'll continue. So let's see if this works. Okay, all right, so I'm going to fire this baby up, and what I need is, when I do this, make sure to put your, make sure, I got an error here, but make sure to put this position in position 1 so that it doesn't take off on us, and we just misspelled backward. Okay, so let's do boom. All right, life is good, and we'll go ahead and fire that baby up. And we'll make sure that this is running. Servo left. Okay, we got misspellings everywhere here, so servo, servo, you probably saw that, didn't you? Servo. No problem, that's why we compile. Okay, we're getting there. Oh, here we go. Okay, so since I have this in position 1 on the power, it shouldn't take off on me. So let's see, it should fire up. New program, takes a few extra seconds. Okay. Now, is it running? Okay, it played a tone, that ain't bad, and now it's off and running. So cool. And our program from before is still on there. So I'm ready. I am ready to see what happens if there's an obstacle. Okay, so I'm going to take an obstacle, and here's my obstacle. Okay, I'm going to put this heavy textbook right here, and when it hits this, it should go backwards. Okay, so now, oh boy. Okay, so here I go. I'm gonna hit reset, and I'm gonna switch into position 2. Here it goes. See what happens when it hits this. It did it. It saw it, backed up. Okay, here we go. Backs up. And yeah, it's flipping my pins out of there. It's working. Okay, so it's kind of doing something. It's kind of acting not exactly as we'd like, but it's doing something. Okay, so let's take a look now. Let's make sure everything's okay here. So I come back into my program, and I have, let's see here. Let's take a look at what's going on. So I come in here and move backwards 1500. and then I delay. Okay, so I don't think I need that delay in there. Oh, I didn't. I delayed, but I really wanted to halt, didn't I? I really wanted to halt. So that was just stupid. So I should have said halt. Okay, so let's see what that does. So I wanted to hit the book, and then I want it to come back. Okay, so let's do this. Okay, so I got mine on here. I'm gonna fire this up. Plenty of time here, and we'll know that it goes when starting Whisker ROM. Okay, played the tone, life is good. Okay, now I'm gonna unplug this, and so here we go. I'm gonna unplug this. Okay, and I'm gonna hit reset, and I turn to power position 2, and here we go. Here it goes. Oh, you know why it's you know why you need it to hit just the left whisker. So what was happening, it was just hitting the right whisker because we only coded it for the left. Look at that, look at that. Isn't that awesome? Certainly isn't halting though, is it? It goes backs for 1. Oh, it's because you got to put a delay after the halt. But I got to tell you, look at this. I mean, this is awesome. So it's going forward. Oh, a little whisker. Yeah, you got a little obstacle there. What's up? Okay, cool. So I want this. So this is just great. We're learning all this stuff. We definitely want to have this halt thing work because it's going to move backwards and then it's going to halt, and then I want it to just stop for a little second here, just a couple seconds. I don't know why it's not stopping, but I think we got her now. Oh, you know what else we want to do? Let's do the following. Let's put this in each of these. So if it sees something on the left, go ahead and move backwards. If it sees something on the right, go ahead and move backwards. If it sees something on both, move backwards. That's why I was kind of acting funky before. So let's see. Now we're going to fire this baby up, and this should be perfect. Okay, so we're going to wait for it. I have it in position 1, so it won't take off. I know it'll download when I see the serial monitor go. Okay, so the serial monitor, and there's my tone. So now what I'm going to do is I'm going to disconnect this. Okay, and here I go. I'm going to hit reset, put it into power 2. Let's see what happens. Here it goes. Alright, it's going to come up. It sees the book, goes back, halt. Beautiful. Look at that. Oh, yeah. Look at that. Look at that. Right whisker? Just the right whisker? Oh, yeah. Nice. Just the left whisker? Oh, yeah. Look at that. Look at that. Look at this. This is awesome. Okay. So now what? Well, here's one last thing we could do. We could do a program where the thing just roams. Okay, so let's do a program where it roams around. So the only difference in a roaming program is that instead of just moving, backwards, it's going to like go backwards and then turn, and it'll kind of just check out its surroundings. So one of the things you can do is say, if it sees something on the left whisker, let's go ahead and move backwards, and instead of halting, let's go turn right 90, and just to make it a little, yeah, that's fine, and then we're off and running. Okay, so we're just gonna let her roam, and then if we see it on the left and right, let's go ahead and move backwards, and then we'll do it sees it on the right, let's go a turn left 90, and then if it sees it on both, let's go ahead and let's just turn all the way around. So let's go like turn left 90, turn left 90. Okay, so let's just see what happens here. All right, so I fire this baby up, and okay, needs a little jump start there. Hit it again. Alright, here we go. Starting Whisker ROM. Okay, so I'm going to unplug this. Okay, and I'm ready to turn the motors on. So let's see what happens. All right, here we go. So here it's cruising along, and it's going to see something. Left whisker. Turns right. Okay, so it's really got some. Try to block this a little bit. It's just kind of cruising around. Got plenty of these textbooks, so we'll just look at that. Look at that. Put that over there so you can see it. And it's just kind of checking out the surroundings. Good thing I got so many of these textbooks. And check it out. It's just roaming around. It's just kind of seeing what's going on. Look at that. Look at that. Almost got them all. Almost got it boxed in there. And it's roaming. It's just checking out what's going on. Sometimes it gets away. Come on back, baby. And look at that. And it's just roaming around. All right, so awesome. So that's basically roaming with the roaming with the whiskers. Okay, so go ahead and give that a shot and play around with different programming constructs and making it do stuff. And so you're getting to the point where now you can make, you're moving the robot, but you're also doing something kind of cool. You're actually sensing the world around you. Okay, go ahead.